Start recording. Hello, YouTube. Okay, so it's been a little while since we've done this. For the YouTube people, it's not because I only uploaded yesterday. But we had this happy little thing, and when we hit space, you know, it separates them and it gets it wrong some of the time. And so we were trying to, when we did this, we were trying to figure out why it got it wrong. And it's something to do with the fact that, you know, we don't treat the order of these things correctly. And we were just like, I guess, I don't know, we were a bit tired by the time because we went an hour over. And so sort of just mucking around. So today's effort is going to be basically actually breaking down this problem and fixing it properly. So we're going to have a little diversion first. So do you know about something called why is this not working? Okay. The thing on screen. De Morgan's laws.
No.
Okay, these are pretty simple. And I'm thinking I will just straight up give them to you because they're kind of just obvious, but we'll go through them. So there's two of them. One is if you have not A and B, that is equal to not A or not B. Is that
this is philosophy elementary symbolic logic course from a million years ago. Yeah, I remember.
So, and then the sort of inverse looks pretty much the same. So that would be not A and not B. Yeah. So, I mean, we can just stop there pretty much, but we may as well write out the table. So we'll do this one first. And so if you've got A and B, and so we've got 0, 0, 0, 1, 1, 0, 1, 1, and we have them ANDed together. So that's 0, 0, 0, 1, and then we take the not of them. That would be 1, 1, 1, 0. By the same token, yeah, if we have not A, so these will all line up, which would be and not B. So these would be 1, 1, 1, 0, 0, 1, 0, 0. Yep. Mm-hmm. And then we all those together. That's 1, that's 1, that's 1, that's 0. And of course, that column and that column are the same. So we've proven that those are equal. And really, there's not all that much point in going through the other one because, I mean, you get the same result. So you sort of just take that for true. But these are things that you need to know. You need to internalize these two equivalences. They're basically like Boolean algebra sort of stuff. If you're trying to solve something, you need to know these. So are you good with these?
Yeah, I mean, whether I recognize them in code or not is a different thing. But yeah, I mean, they're pretty straightforward.
Okay, so these will come in handy later. So there's our little diversion into that. Let me see, what are we doing? So last time we had a really ugly diagram and it was pushed over into the corner and it was like down here in a little box, and it looked kind of like this. We had, you know, a square and a square, or we had like a square, or I guess a rectangle and a rectangle, and we were like, well, these can be like, are these A and B, or are they B and A? What order are they in? We're handling one of them correctly and one of them not correctly. So we had like, here's, maybe I should have done the colors differently. Let's do that differently. Let's make this a bit clearer. So we have two different ways that this one can go depending on which one is A and B. So we can have it like, this first one is A, and we'll do that in red. So it could be like that, or the second one could be A. So it could be like that, and this one could be A over here, or this one could be over here. And then we have the opposite. So we have that and that, or we have that and that, and then that and that and that and that. So depending on which one is A, so B is green and A is red. And so it really depends on what order they're in. And we're handling one of these cases correctly and one of them not correctly. So this would be like A start and A end and B start and B end and so on. And so that starts to get really complicated because obviously we've got 1, 2, 3, 4 cases, and they're all like a string of bloody Christmas lights, and so that's not really a good way to handle this. So let's break down this problem in a slightly different way. We're going to basically ignore this diagram. We're going to look at this one primarily, and what we're going to do is look at it as a single axis. So we're going to ignore the fact that they're boxes and stuff, and we're just going to be like, here's our axis, and we have, say, 2 shapes that we're representing, and we're doing this on an axis. So it's it's the thing that we're doing. It's the separating axis theorem. And so what that says is, if we can draw an axis in between these things, or if we can find a space between these two objects on a given axis, then they're not colliding. So that's all we want to find out for now. It's like, are these not colliding? And if they are colliding, if they're not colliding, then they are colliding. So we're just going to work it out that way. And so there's basically 2 cases, as we can see here and here, where they are not colliding. So we'll draw both of them in. So if we have A start and A end, and this one could be A start and A end, and then we have B start and B end, and B start and B end. So there's 2 basic operations that tell us that they're not colliding. So I don't suppose you want to take a guess at what those might be?
What do you mean when you say operations? You just mean like tests?
Yeah, so
equivalence tests?
If blah.
Right.
How would we detect that case? Or each case?
Right. The case that they're not colliding, or the case that they're not colliding?
So we're detecting this case, the case where we have a separation.
Okay, right. So B start has to be greater than A end, and B end has to be greater than. Well, I guess we're reversing it. I wanted to say B start or B end has to be greater than A end also, but I don't think that's 100% right. Because you're saying it could be like we could be flipped, right? But I know for sure that B start has to be greater than.
So we know for reasons of how we've specified this problem, because we're projecting down onto an axis in a particular way, we know that we're never going to have this situation. We're never going to have the blue situation, which is B end and B start. So
right.
This is why I've drawn like these arrowheads here, because we know we have, even though we've got one axis, it's positive is that direction.
Mm-hmm. I'm not sure if we need to do anything more than in this case than for that top line,
So,
other than
yep.
I mean, if it's arranged exactly like this, then I think that's the only test I care about.
So this is correct for the top line, but obviously the bottom line has to be different. But the bottom line is pretty obvious. Do you want to take a punt at it?
Yeah, A start has to be greater than B end.
Greater than B end. Okay, that is correct. I have it written the other way around in my notes. I've got A end is less than B start, but I don't think that matters. But what does matter? So let's jump ahead and talk a little bit about 0. So let's say that we have, what we're going to do if we have these things overlapping is we are going to separate them out such that they are not overlapping. And so the distance here is going to equal 0. Now, if the distance here equals 0, what we're basically saying is, if this is our B start, and this is our A end, these are going to be 0. Well, the difference between them is going to be 0. So A end equals B start. So what we actually need to do, so what will happen then? We've done our separation phase. We've got here, and we're detecting that they're not intersecting in this test. So what we need to do is say that when they're touching, we don't have any further work to do, because otherwise we'll keep, detecting that as an intersection, separating it by nothing. Yeah. And get stuck in this constant loop, and so that'll waste a lot of processing time, for example. So all we have to do is stick those little equal symbols in there.
Sure.
So let's make a new layer for this. So how are we going so far? So not intersecting. So this is our test in the end, and I'm going to switch the order just so I can follow my notes properly. A end is less than or equal to B start, or B end is less than or equal to A start. So if that's our test. So are you happy with that, aside from how scrappily it's written?
Yeah, makes sense.
Cool. Let's neaten up that diagram. Okay, so this is how we detect that they're not intersecting. But we, if not intersecting, great. But we want to detect, else. We want to detect the opposite, and do stuff.
Mm-hmm.
So what we want to do is then take that thing we were looking at before, the De Morgan's law, and do basically, I'm actually going to erase all of that. Actually, let's do the opposite. So intersecting test is going to be not. It's going to be exactly the opposite. So not A end is less than or equal to B start, or B end is less than or equal to A start. Okay, so this is how we test that they are intersecting. So are you sort of happy with the logic that's gone into that?
Mm-hmm.
Yep. Okay, so what we can do, like this, now we have this obvious thing. It's not something or something. And this is like, whoa, everyone pay attention. This is one of these things. And so
yeah, not clause 1 and not clause 2.
Exactly. So we can very quickly do the substitution. A and is less than or equal to B start. And so if it's not that and it's not this, and you can sort of think about De Morgan's law like this makes sense. If it's not that or that, it's not that
Not
and
that,
it's not that.
and-
Yeah.
Yeah.
So it sort of makes intuitive sense too. And so what we can do here,
Decompose that down further.
we can. So that becomes A end is greater than B start, and B end is greater than A start.
Cool.
So if we know that this is true and we know that this is true, then we have our intersection. And so if we sort of try and draw that out, let's draw sort of rectangle-y things again. Someone's hammering in something into the wall behind me. Weird. Okay. Let's see. So if this is a start and this is a end and this is B start and this is B end, we can sort of go through this and is A end greater than B start? And look, yes it is. So we're comparing those two pairs. And the other one is B end greater than A start? And we're comparing these two pairs. And in both cases, like yes and yes. So you can imagine one of the other combinations, like let me see, that and that. If we have, if B came all the way along that way, we'd have A end and A start and A end and B start and B end, and we look at this thing, it's like, is A end greater than B start? A end is definitely greater than B start, which is, I guess, that one and that one. But is B end greater than A start? And you look at that and no, it's not. So you have to wait until this gets close enough into there before these two pairs actually cross over. So that's how that works. Does that all make good quality sense?
Sure.
Excellent. Okay, so here's sort of here's the bit where we think about separation. So, and this is where this sort of becomes like links up this particular formula. So, say we have this condition, and we want to get to like a condition like this. What this tells us is there's two different ways to to separate these two shapes, and they can be such that we make this term false or we make this term false. And that kind of goes into what direction we're going to separate in. So if we have A, I'll try and line this up. If we have A sitting here, and we want to invalidate, let's invalidate this one first. So, this one. We want to invalidate the case where A end is greater than B start. So what we have to do, if we're moving B, is increase B start to the point where it's going to end up over here. So what we've done is, we've moved the whole shape like that, and we've increased B start so it's now equal to A end, which makes that condition false, which makes the whole thing false. So does that make sense?
Yep.
Okay, so the other way we can do it is, we could, and again, we're gonna think about moving B, and we'll talk about a little bit about why that is in a moment. So the other way we could do it is we can move B so that it's there, and that would invalidate this other condition. So that would be like, what we've got, B end and B start. And so we've basically, what have we done? We've decreased like minus, 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 B end until it's equal to A start. And so that is basically going the other way. So it's like, that. And hey, we've separated it again, only we've done it in the opposite direction. So, in this case, it was like from here to here. In this case, it was like from here to here. So, making sense so far?
Yep.
So, as we were doing with the separation stuff, we always want to consider, like, even on this. Can I have my? Has my whiteboard crashed? That would be very sad.
I like that diagram.
I was quite happy with this diagram too. Oh no! Don't crash. Come back. I might have to kill this task. That's kind of tragic. There will be a process of careful screenshotting to restore this diagram for the upload. But in the meantime, we're gonna kill the GIMP and start it up again.
Time to get a new machine.
Yeah, I don't know. Who would have thought that installing a Microsoft product would do this to a computer? Oh dear, I'm such an optimist. Okay, so right. Anyway, so we had. Let's write that down before we forget what we were doing. So we had. Now I'm going to fix up my brush. I'll have that one, please, and that one. Okay, so we had A end is greater than B start, and B end is greater than A start, and then we can either, we can invalidate these conditions by moving A or B around until they are, equal. And we can do that to either side, and then we will know that we're not separating. So I want to choose the minimum amount to do this. So let's see. Let's change the way we're thinking about. Okay, no, I'm going to change this slightly from what the notes say because I've done this in a different order. But okay, so what we were doing. I need this diagram, so I'm going to have to redraw this diagram. So if this is A and this is B, we can either separate out this way, or we can separate out B by subtracting that. So and then that is going to be that, or that is going to be that. And so, and you can imagine that, if they're overlapping the other order, for example, this still might be a valid case. It's just that obviously this one diagram is going to be the other way. So let's see. So
we're choosing the minimum distance because that's part of SAT, right? We're not just choosing it for aesthetic reasons.
Well, I mean, you can choose any so there's two reasons you want to choose the minimum distance. I guess. So let's think about the other way around. Like, why could we choose that? And the thing is, you can. If you're just trying to separate the shapes, it doesn't really matter. But if you have a bunch of shapes, we are trying to reduce the amount that we're moving the shapes around. So you recall when we were had a whole bunch of shapes overlapping and we iterated on them very quickly. We want to get the amount we're separating by down to 0 as soon as possible. The other reason is, B, in most sane situations, if B is a box coming in and it's going to collide with A here, odds are, unless you've got B's moving ridiculously quickly, the next frame is going to land here. It would be very strange for it to cross over sufficiently to land here, because in that case, you'd be separating B out in that direction and be oh, B hit that wall, and it's no, it didn't. Whereas it's sort of perfectly normal for it to be B hit that wall. So in most sane situations, when we're using this result to detect the impact direction of B onto A, that will tell us sort of that the surface normal.
Okay, well, I mean, I sort of don't quite understand the idea about... your second point makes perfect sense, because, I don't often, throw a ball against the wall and have it bounce through the wall on the other side. But the idea that it's because we want to get to separation as soon as possible wouldn't... if we chose the distance, the longer distance to push out, we would get to 0 on the first try, wouldn't we? Because we would have... the distance would be calculated just larger.
I'm thinking in the case, say we have I don't know what sort of game we'd be making, Breakout or something. If we had two shapes here, and we have B coming in, and it intersected here, if it were to snap out that way, then it would just end up here, and oh look, we've got another collision to deal with, and so it just takes more steps. Whereas, so this is basically what I was describing as the case where you have many shapes.
Oh sure, yeah, I missed that first time. Yeah, that makes sense.
Okay, so let's try and do the maths for this situation. So in this case, which is the first one, we're trying to get it so that B, we're increasing the position of B such that it will be, such that it will be out equal to the A end. So we can do that because we know how much just with these two values. It's that much. So it's A end, B start, and we just subtract the two and to get that positive difference. So in that case, that is, we are B plus, plus equals A end minus B start.
Right.
Minus B start. And so A n minus B start is that vector, and we're just moving all of B, that amount to get there, or I guess that amount. This one is the opposite. So we're taking B and we're going minus equals B end minus A start. Minus A.
Isn't it B n minus A n?
So actually, now let's make that a bit more. So, we want this negative vector. So it's, sorry, what did you say?
Oh, I just thought maybe it was B end minus A end, because that's the amount of, that's the distance that is not penetrating.
B end minus A end. So so that's that one there, and that's that one there. So if we subtracted that distance there, we'd still, no, the distance we're subtracting is this one here to this one here. So basically what we're trying to do is move that.
I fell for the same thing with the circles.
Yeah.
Yeah.
So we're trying to move this edge all the way back there. Obviously that's
That's
quite
right.
large, but in other layouts of this problem, it might be the smaller one. So that distance going that way that's a start minus b end. It gives us that vector there.
Yeah, I blame your
so-
little blue arrow on the second example at the bottom.
Yeah, that's
I was
totally
switching-
wrong.
Yeah,
Good catch. This is bollocks. That's nonsense. Good. Yes, that's very wrong. It should, in fact, it should be, if we're starting from there.
we wouldn't start from
Yeah, we wouldn't
there.
start from there. That's insane.
We would start from way over there.
Yeah, we'd start
Yeah.
from
That's right.
there and go there.
That's right.
That
Okay.
now it makes a lot of sense. Okay, so and we've got, what is it? A start. A start minus B end. So we're adding that. Now, obviously, these are going in different directions. So to get the minimum, we want to use the absolute value of blah to get the minimum. But we actually know the directionality of this. We always know that this one is going to be negative or positive. And there's a reason for that.
Oh yeah, we have the conditions in our operation above, so
So we know that
which one's bigger.
Yeah, we know that this one is always going to be negative. So we can start doing some algebra. So rather than doing this, let's flip this around. So first of all, that would be, if we're moving B, what would that be? So I'm just thinking about how this goes. So we want to subtract that so that we basically are working on like this arrow here and subtracting it. And there's a reason for that, and that is we want all of our arrows going in this direction so that we don't have to, use an absolute value to flip them around. So we're going to do B minus equals, and then we're going to, flip these around to get the negative, which would be B end minus A start. So what I just did there, I kind of rushed through that, but does that make sense?
Yep, it does.
Good. And you can see it's sort of pleasing, like these two conditions are effectively the same. Like it's just reversed.
Right.
Now, the nice thing about this is now that these are all positive, we can just compare them directly. So we don't we could say separation equals okay, so we could say, so here's the tricky thing is we actually want both. We want that plus equals, but we also want the fact that these are both positive. So we have to do the code in a sort of funny ways, because we could say separation equals the min of A end minus B start, or B end minus A start. So that will tell us the amount we're separating by.
Mm-hmm.
But it won't tell us this business.
The
here.
directionality of it.
Because what this actually is, and this is why I've kind of, like, this was tricky to write in my notes in the first place, because this is actually what you'd be doing here. This is equivalent. Like, this is interchangeable. B end minus A start. So, because you recall when we were doing the circle thing, we could either move B forward to separate out, or we could move A backwards. So this is the equivalent thing here.
Mm-hmm.
So we can't simply say this, because we lose information about, do we want that and that, or do we want that, or do we want, this B plus. So instead we have to be like, if, you know, if A end minus B start is less than B end minus A start, and then you'd probably have to do this slightly differently. You have to be like, okay, so the separation is, I guess you could just use, what was it? Where's this one we had before? So if A n is that, so separation equals A end minus B start, else separation equals negative. Now this is a smaller one in this else case, negative B end minus A start. And so in all of these cases, this separation that I've drawn here, this is like separation for B. And so you recall when we were doing this before with the circles, if we always figure out how much to separate B by, you know, that amount there, we can go ahead and we can like divvy it up. So we could be like, okay, we're going to separate B by that, sorry, A by that and B by that, or, you know, we could just flip the whole thing and send the whole thing to A, or we could like do some balance calculation using the mass of the objects and so on, just like we did before. So anyway, that was the entirety of the whiteboard session. So now we just need to implement this. So this now we have the maths, and it's basically, if these are true, it's intersecting. Let's clear the intersection with some separation, and we have to do this on two axes. So in fact, this will be slightly different because we actually have to check what is the minimum separation twice for each axis and get the total minimum separation for shape B, whatever shape B is. Does that make sense?
Yeah. Sure.
So this is the magic. This is the magic sauce. So what it might be useful to do. I'm just thinking, what's the most expedient way of doing this? I think so. There's two ways we could do this. We could try and draw out. Recall before when we had the circles that you know, what we would do is if they were intersecting, we'd just draw a line and be like, yeah, they're intersecting, and then deal with how much to separate them by later. So we could go down that road, or we could just flat out just hope that we know what we're doing and just code directly without any sort of diagramming. How are you feeling about which one would you prefer?
Let's just code it.
Let's just code it? All right. Sounds good. Hopefully we've drawn enough diagrams to know what we're doing. But yeah, it always helps when, we got stuck yesterday. It's like, let's draw out the diagram and figure out exactly how this goes. So A end is greater than B start and B end is greater than A start is our magic sauce. Let's get to the coding part. So we've got rectangles, we've got an x-axis, and we've got a y-axis. So, and we kind of have something sort of similar to that going on, but it's not quite correct.
I think we're doing all that separations, like toy mass stuff, the way we should be. Was just calculating the values. I mean, I just don't know if we have to do something different for y, because I did literally that here.
Well, let's say I'm pretty sure we've got this correct. Rectangle position x minus the radius plus the radius. So this minus radius plus radius tells us that start's always going to be less than end on this axis. So we have that condition right, and these is all right. So let's just wipe that out. And I think our did intersect is actually correct as well. So let's just do this straight up from scratch. So
I don't wanna. I already did it.
well, not actually. Yours is fine.
Still wrong.
B start and B end is greater than A start. So this is the case where we intersected on the x-axis.
That's right. So is it not A end minus B star to get that?
Okay, so here's where we have to change what we're doing. This is the reason why it was working on one side of the shape but not the other, and that is this is clearing A end minus B start is clearing this part of the condition. But we also might want to clear this part of the condition because it might be smaller, and then we won't fly through the shape.
Oh, right. We forgot. Yeah, there's the min bit. I don't know if we wanted. I mean, don't. I think we just avoided that in the diagram, so I don't know if I'm doing something dumb here. But,
well, I've kind of shortcutted this because this is the same as this. So let's just say.
Okay. Yeah.
Let's so that's float. A is so to separate A was now I've got to make the diagram bigger again. So separating A was B end minus A start. So that clears out this part.
Okay, I'll just follow you.
Okay, so now we have that. I mean, I've already written this code, so let's just copy it. Let's be a little bit lazy today.
I kind of have a hard stop at like 9:20 or whatever we started after an hour. Well, no, I could go a little longer. Okay, so yeah, that's just what we have here. Yeah, wait, hold on. Separation B. Yeah.
I've reversed that condition. So it's actually that in the thing that I've written here. Separation X. So this is the x-axis equals B is smaller, else so the important thing is, does this code make sense?
Yeah, just give me 1 second because I just want to compare it. Like, it's like the reverse of the green. No, like separate. This first one is like the condition of A end minus. So that's B on the top there.
You've kind of pointed out a bug. Should be that.
Oh, okay. Yeah. Sure.
Because you'll notice. We have that in there as we were discussing because we are doing the separation for B.
Yeah, but in our version here, if B is less than A, in our separation B as in it is A end minus B start, but in the other diagram it's the reverse of that separation. A is A end minus B start.
Have I made a maths boo-boo? I think I probably have. B end.
Well, I don't know about that. I think it's more just like it's not exactly the same as it's the reverse of like A should be A end minus B start, right?
It should be that, shouldn't it?
Yeah, that's right. I think so. I mean, I'm just following it. Literally there.
Like, this is the thing. Is it's really possible that I've made an error. So let me have a quick think. So what we want to be, this is the easiest way to think about it, is this case here, and that is we want to add A for separation A, and so that's B end minus A start. B end minus A start. No. Yeah. So it could be that this diagram is wrong, and this is correct.
Oh, okay. Oh, okay. So B. Okay, yeah, yeah. Okay, so I just flipped it to make it like the green, but now I think you're saying the other green is good. Like I've got A. The separation A is AN minus B start, where and then therefore negative B is for the BN minus A start. But yeah, I'll just flip them back around.
Let me have a think about this for a second. So okay, we'll do it from the diagram again. So float separation A is definitely this one, because this one is moving. This one is effectively moving A, so that we get.
That's
we get it to the. We get A start to B end.
Start B. Yeah.
So this is how much separation we need if we moved A. So B end minus A start.
Yep, I see that.
And then spelling equals, now this one is just the opposite, A end minus B start. So this is moving the start of B, so it's at the end of A. So all we have to do is pick which of these is smaller. So if separation A is smaller, then we want to choose that one. But we never want to separate A, so it's separation X equals negative separation A. And that's kind of just a convention. Like if we're always, as I was saying here, if we're always separating B, then we know which direction we're in. We can like divide it up later based on the mass and stuff. Otherwise, separation X is just separation B. And that's just all garbage. So, and that matches what I have in my notes. So hopefully it's right.
More importantly, yeah.
And if it's wrong, we can just debug it. It's fine. So in theory, and this is the nice thing about this algorithm, is that now this just works for the next axis.
The A's starts and ends don't change because those are on the different axis.
Yeah, so these are all correct. We copy this one down and we just need to change that to Y. Okay, so in theory, we've fixed the bug. We're happy with did intersect, so if they ever don't intersect like this, we set that to false and it's like, yeah, they're not touching. And we don't do this. But if they are intersecting on both axes, which we set up here, we run this thing. We've got the mass, we've got the happy about that formula, we've got a separation, and we multiply it by the axis. So let's give it a go. So on this axis, that works. That works. Now on the other side is the big question. And it seems to work.
Nope.
No, we've got a bug. Because
if I do this guy, he's not going to get kicked out the top. He's going to kick out the wrong side. Yeah.
Yeah, and I've got the same thing in the opposite way. So this should be a simple bug. So you'd think this one should get kicked out to the left, and it's going to get kicked out up, and it does. So that should be really simple to fix.
You say that now, but I'm like, this is like last time part 2.
Dun, dun, dun.
What's the possibility? The possibility is that the other one was we've got these flipped around maybe, but it's not always making the wrong choice. It's only ever making the wrong choice on the one axis, right? It's not making the right choice on the y-axis.
Like it's possible I've made an error. You're quite right. No, it's not making the wrong choice on the positive axis. So you can see that this one works, and this one works, but
that's right.
Oh, that one worked. Hang on. This one's going to fail though. So maybe I have made a mistake. Maybe these ones that I'm claiming should never be... Oh, this is interesting. This is interesting because although I removed the problem with the absolute value here, I've introduced it here because I've gone and set that negative. So we're actually pushing like two pieces of information, that is the direction and the separation. And so this condition is ending up wrong. So what we need here is to take the absolute value. So that's fine for now. So do you understand how that happened?
Mm-hmm.
Yep.
Yep. It makes sense now.
So what I'd like to do eventually is get rid of this abs, because we're just, we're negating something and then taking the absolute value. It's like, well, that's a wasted operation. But for the time being, this will do. The reason I think we can get away with removing this is because we're going to probably turn this into like a loop. So it will be like, here's a possible separation, here's a possible separation, here's a possible separation, here's a possible separation, 1, 2, 3, 4. So we've got 4 cases, but when we start getting triangles and like multi-sided polygons, we're going to have like lots of cases. So we'll probably end up turning that into a loop, and it will just get handled in that way. So now, hopefully, whoops, yeah, that's all looking good.
No.
No?
Well, yeah, actually, yeah, never mind. I just got my logic crossed up. This one should, like on my screen, that one should get kicked out the left side because it's actually less distance than the top part.
Yes.
So yeah, that's fine. Yeah, it makes sense when I think about it. Cool. Sweet.
I think let's actually finish on time this time, and with a working program.
Wait. No, I just have to keep pressing. I forgot that it's iterative. I got to keep pressing the space bar to get closer to the.
Yeah. Once we have masses that like move around and don't actually start inside each other, like this case will never come up.
Spontaneous Pong. Multiverse Pong.
But it's pretty satisfying. It's like, hey, look, they're all separated cleanly.
Yeah, I'm happy with that.
Sweet. All right. Any other questions before we end the show?
No, I think I'm good. Yeah, next time I guess we're gonna do the loop.
Probably. I think. Although, as we were saying, we could leave it with just squares and circles. Actually, what we probably will do, what we'll probably do is rectangles versus circles. So integrate these both into the same system, because you'll notice that like that is pretty much the same code as that, and this is sort of similar, but not quite, because we've taken some, liberties with it. So we might adjust this so that it fits into this system, even though like by simplifying this, we've saved a couple of operations. We probably won't have so many circles that we actually care about that from a performance standpoint. So we'll just unify all of the code, and that'll probably be faster anyway, in the grand scheme of things.
So, this is going to work for separating circles and rectangles that are overlapping?
Yeah, so that's where we're going to go with this next time. We'll have to basically have to take all of this code and merge it together, so that instead of like deal with rectangles, deal with the circles, what we'll probably do is deal with all of the shape combinations, and each pair of shapes will generate a series of axes that they need to test against. And then we'll just take the best axis in each colliding case. And then obviously once we have that situation going, it's going to be really easy to add in like polygons and stuff, because it will effectively, like this bit will be the same.
Does this mean we have to go back to like a really good understanding of Minkowski, because we're going to be doing like rectangle versus position, which is the circle's position?
No, it's all going to be separating axis style.
Perfect.
We don't even have to think about Minkowski at all. So it'll be very similar to this, but we're just taking this and making it more like this one, really.
Okay.
Yeah, so I'll have a think about what we'll actually... I'll make our lesson plan for that, and then we can do it. Okay, where's OBS?
Great.
Yes, and I'll I'll go through the video and take screenshots and fix the whiteboard upload. Sorry. All right. Goodbye, YouTube.
No problem.